Hi, in this video, I'm going to discuss the last 8 of SLJMCC 4 and the second 10 of SLJMCC 5, given last year. Okay, let's go to the questions. Okay, let me share the whiteboard. Right. Hope you can see my screen with the new whiteboard. Now, first of all, I'm going to erase some of these so that I have space to work. Okay, my pen is not working as fast as I would like it to. Now all these erased. Okay, let's go to the question. I need to get my favorite color, light blue, a cool color. Right. Let's see question number 17. If Abdul gave 15 marbles to Meena and 9 marbles to Sarat, then they all had the same number of marbles. How many more marbles does Sarat have than Meena? Right. So after this exchange of marbles, right? Actually, not exchange. Abdul gave, he is very generous. He gave 15 to Meena and 9 to Sarat. Then they all had the same number of marbles. So let's draw a diagram, right? So show that they have the same number of marbles. So 3 horizontal line segments. And this is Abdul before he had this, thought of donating marbles, and he's Meena. No, this is after the donation, right? After the donation, Meena Sarat. So after the donation, right? After Abdul gave 15 marbles to Meena, that means Meena was actually down by 15, right? Before this donation, right? And Sarat was down by 9 before Abdul's donation, right? No, I had to write not 9, not there. Here, right? 9. So these, we get a different color. So these two, now I can see this little dot to tell me where the pen is. Same as something right there, but I can't see. Let's get a different color. Red. Still I can't see. Right. So what does that mean? Do something right now. Still I can see. What is that? I can't see where my pen is. So let me remove it, reconnect. So if whenever your computer gets stuck, right, there are two things you can do. You can refresh or you can restart. So I just unplugged my writing pad and then replugged it, hoping that it will work. Still I can't see my pen. Right. So let's do something else with this. Move it down. So if something is not working, there's another way you can actually get it to work. You can kick it, right? All right, now I can see the dot, right? Now, then, before this Abdul's donations, right? Meena was here, right? This red horizontal line, and Sarat was here. So that means Sarat was had how many more than Meena? Actually, 6 more than Meena, right? So that's the question, right? How many more marbles does Sarat have more than Meena? And there is actually 6. Okay, let me go back to my favorite color, light blue. Blue. Right. Okay, number 18. Um, 18. Right. Each figure in the following sequence of figures is obtained by adding a column of dots with one more dot than the dots in the rightmost column in the previous figure. Yeah, previous figure, rightmost. So if I look at the second figure, right here, so this is the rightmost column, right? And you can see that, well, this is the rightmost column of the previous figure, and one is added, and this is the rightmost column, right? So we could get this by adding one to this column, right? So that's how you generate this by adding a column, right? By adding a column of dots with the other column, and this column has one more dot than the dots in the rightmost column in the previous figure. So that description is accurate, right? How do we get get a figure in the sequence? You look at the previous figure, and then you add a column to that previous figure, column to the right, and that should have one dot more than the rightmost column of that previous figure. Then how many dots in the fifth figure? And the fourth figure, right, should have, so these dots, how many? 1 plus 2 plus 3 plus 4. These are triangle numbers, right? And you add one column with one more dot, that is the fourth figure. And the fifth figure, so this is a fourth, fifth. So you add one more column. Now this is the number of dots that previous figure had. 1, 2. So this is actually not. This is the fifth one, right? So mistake. So the fifth one actually should have this many dots. How much is that? How many? So here is 6. I always add in blocks. That's easy. 5 plus 4 is 9. So this is 15. Right? So when you go to the shop to buy things, right, you can actually figure out the amount you need to pay, right? So prices are there, you add in blocks, right? So there are 15 dots in the fifth figure, right? Okay. And then number 19, each figure in the following sequence of figures is obtained by adding one more outer layer of dots in the shape of a hexagon to the previous figure. Right, for this, the previous figure is just one dot, and you can see that there is actually outer layer of dots in the shape of the hexagon, right? So, so here's one dot, here's 1 plus 6, and then here we add another outer layer of dots in the shape of hexagon. And how many dots are here? So this one has, so the previous dots in the previous figure, 1 plus 6, and so there's a hexagon, and you can count, all that, but I'm going to be doing a lazy counting. So each side has 3 dots. So it is 3 and 6 sides, right? 18, but I did a overcount, right? So these dots counted twice. This one, this one, this one, this one, this one, this one. 6. Right? So it is 12. So then the third figure has 1 plus 6 plus 12. So what is the fourth figure? Fourth one. So 1 plus 6 plus 12. Now, the outer layer of dots in the shape of hexagon, that will have one side 4 dots, right? Times 6, right? And then when you subtract, you take away the double count, right? 6. So what do you get? 24 minus 6, 18. So we get 18. So it looks like multiples of 6, right? Let's see. There's a fourth one, the fifth one. Fifth one. Hold on. Fifth one. So what? First, second, third, fourth, fifth. Fifth one. So again, these number of dots plus the outer layer, new outer layer. Now that you have 5, right? On one side, so 5 times 6, and the double count, subtract 6, take away. So that is actually 24, right? 30 minus 6, 24. Yes. Yeah, actually, there's a pattern, right? Multiples of 4. So I'm going to add this up, right? Again, in blocks, that's my favorite way of adding. So 12 plus 18 is a nice number, 30. And this 24 and this 6, another 30. And then there's a 1. So it is actually 61. So there are 61 dots in the fifth figure. Right. So let's go to the next question. Questions 20 and 21 has this table of figures, right? And then this asks how many figures have parallel lines, an interior right angle, and less than 6 sides. Okay. Now, what are parallel lines? So 2 lines or more parallel, if they do not intersect, that means cut, right? Or meet, right? If you extend these lines as far as you can to the infinity and beyond, right? Okay, how do we understand this? So if you have you seen these parallel lines, very straight. So there are 2 rays, right? And they never meet. Parallel lines, right? Okay, let's label the figures with parallel lines P, parallel, P for parallel, right? So here I don't see any parallel lines, no P. Here I can see, right? So these 2, these sides are parallel, right? And these are parallel, yeah, those are 2, yeah. And then here there are lots of parallel lines. So I'm going to write P here, no parallel lines here. D, E, there are parallel lines. And Avis also has, yeah, these 2 are parallel. P, and this also has parallel lines, right? This, and this, and this. And then this one, 2 parallel lines, right? You can even write like this, parallel, right? And this one also has parallel line, right? So this, and this. I don't know whether that's the right way of indicating parallel lines, so I have forgotten it, right? So if you know, just let me know in the comments, right? When I upload this in the YouTube. Okay, so except A and D, others have parallel lines, right? Is that correct? Yep, correct. Right. Interior right angle. What are right angles? Interior means inside the figure, right? So if you take, let's say, let me draw a figure, right? Some weird figure, right? I mean, this is not that weird, right? I can make it more weirder, right? Yeah, but what I mean, I'm just trying to tell you what interior angles are, right? So these are all interior angles, right? So when you draw this, right, a curved line to indicate the angle is inside the figure. Now these are also having see, so that's also actually right, something like this. See this one. So here this angle is interior. This one is interior, right? This angle. All right. Right angle means perpendicular, right? There are lots of right angles in your home, right? Because rooms have, these walls at right angles, right? Lots of right angles. And the desk, yeah, corners, right angles, mostly, right? So this is, we denote a right angle this way, like this, right? We draw a little, so here, let's denote right angles here, right angle, lots of right angles, right? And here, right angles, right? Okay. No right angles in D, no right angles in E. F has right angles, right? And G has right angles. And H doesn't have. I also has one, right? So this is also right angle, right? Now this actually is interior, and exterior actually we have right angle, but that we don't count. So this one actually we don't count, right? All right. So, and then parallel lines, interior right angle, and less than 6 sides. All three have to be satisfied by a figure for us to count it. Right? Right. Less than 6 sides, that's the easiest one to check, right? So this has actually, this has 5 sides, 5. And this is for a quadrilateral, this is a pentagon, 5 with 5 side pentagon. How many sides this has? 1, 1, 4, let's see. I think this has 12 sides, right? Am I right? 12 sides. So this is, so this is an octagon, right? No, not an octagon. I don't know what the name is. Can't remember. 4 sides. This is 6 sides. This 5 sides. Again, pentagon. So here, 1, 2, 3, 4, 5. 5 pentagon, another pentagon, right? And this 4 quadrilateral. And how many? Here, 1, 2, 3, 4, 6. So this is hexagon. I see. Right. So 2 hexagons, right? Now, when in higher grades, you will learn something like, there's a E is a convex hexagon and I is a concave hexagon, right? Anyway, doesn't matter. So then let's count. Let's say 6 sides and parallel lines and interior right angle, how many? So let's use a different color, light blue. So this is correct, not correct, not correct. Okay, we not which one. We need to count, count, not count, count. So how many? There are 3. So there are 3 figures, right? All right. Hope I did not make a mistake, right? If I did, let me know in the comments. How many figures are not regular and have an acute angle and an obtuse angle? Right? Regular means the shape is regular, the interior angles are all the same, and sides are all the same in length. Interior angles in degree measure, they are the same, and sides, they have the same length. That's a regular shape, right? So now we talk about, getting in shape, so regular shape. Yeah. Acute angle, what's an acute angle? So less than a right angle, right? So here's a right angle, right? And if you take any angle, right, like this, right, between 0 and 90, it's an acute angle, right? An obtuse angle, well, here's the right angle. Actually, I'll draw a straight angle. So here, 2 right angles, right? And an angle like this, right, is obtuse. It is bigger than 90, bigger than right angle, and less than a straight angle, right? Between 90 and 180 in degrees. So acute angle between 0 and 90. Right. We better erase this thing, right? Otherwise, we all get confused, right? So at the competition, right, you can use rough paper, right, to do this thing. So I don't have rough paper. If I have, but what I do on rough paper, you can't see, right? So I need to erase these, right? Okay. So not regular. So this is um, regular, right? This is not regular. So I will only indicate the regular ones. Again, I can't see my pin. So this is regular, right? Yeah, these are the only two regular shapes. So then we look at other ones, which have an acute angle and uh, obtuse angle, right? Right. So here is an obtuse angle, uh, obtuse O, here acute A, right? Solar. No. So here, so this is not an obtuse angle; it's a reflective angle. It's more than one straight angle and less than two straight angles. Right? So it's a not here acute, here acute, here acute, but no obtuse angle. Right? So this is correct. So not correct. It's regular, not correct. I mean, do not count, do not count. This is regular, do not count. And this one actually, yeah, these two are obtuse, but no acute angle. So we do not count this one, right? And here we can see obtuse, but no acute angle, so we don't count this one. And acute, obtuse, so we count this one. So this is acute, obtuse, and this is reflective, right? But then we have to count this one, right? So there are three, right? Is that correct? Only three. Let me see. Right. This one also we need to count. So we made, no, we don't count because no obtuse angle. D is not correct. We don't count, right? So only three, right? Only three. So the answer is three, right? So what are the figures satisfying conditions in 21? So B, right? And D is not. And then we have F. And then we have G. No, we have H. And I. See? Good thing that I, looked at it again. So there are, so, now F we do not count, right? Only, so we do not count F. Yeah, F we do not count, so only three. Yes, correct. All right, let's go to the question number 3. And sorry, not 3, 23, right? All right. Wait, for questions 22 and 23, consider the following factor tree. You know factor trees, right? So this actually used to factor a given number into primes. So we use boxes or rectangles for the numbers, right? For the starting number and other numbers, right, which are not primes. Circles are for the primes. So if you look at these, what you get actually in this circle, these are the primes. So you get primes in these circles, right? So you get branches and the branches in with primes, right? So 270, right? So this is like 27 times 10, and 27 is 3 times 3 times 3, and 10 is 2 times 5, and those are the primes. And then in these circles, we get 3 threes, 1, 2, and 1, 5. Then how different numbers can n be, right? So n is a product of 2 primes, right? So we need to take these primes 2 at a time. So 3 times 3 is 9, and we can get 3 and 2, so that is 6, and we can get 3 and 5, and that is 15. That 5 is very ugly. 15, and then you can get 2 and 5, right? So this is not multiplication, comma, 10. So 9, 6, 15, 10, all are different. So it can be 4 different numbers. That's the answer. How many different numbers can m be? So m actually is a product of whatever the prime you get here and n is a product of these 2 primes. So actually m is the product of 3 primes. So you take 3 at a time and multiply and see how many different numbers you get. First, we get all 3's, and this is 27, and then 2 3's and uh, 2 3's and a 2, which is we get 18, and 2 3's, and so I'm actually doing a systematic listing, right? So this is 45. Now I'm going to take only 1 3. So this is 1 3, 2 and 5, right? So 3 times 3 times 2 times 5. Then actually we have to take all, yeah. So then this is 6 times 5, 30. And that's all, right? So we take 3 and then we take 2 because we are taking 3, 5. We don't have 2 2's, we don't have 2 5's, so that's it. So how many different ones we get? So let's take a different color, right? We have lots of colors here, unlike, so we get 27, 18, 45, 30. Again, 4, right? So m can be 4 different numbers, any one of 4 different numbers, right? Yes. Okay, now we have the last question, right? How many 4-digit numbers consisting of digits 0, 2, or 4 are divisible by 4, right? So it's not 0, 2, and 4. Then, of course, there's no 4-digit number, right? Of course, then we can repeat one of those. Yeah, it is 0, 2, or 4, we can repeat. Yeah, fine. Otherwise, we can't get a 4-digit number. Now, this 4-digit number, I'm going to draw 4 boxes for the 4 place values. There are 4 place values. And the last 2 boxes, right? So the numbers you form, right, with the last 2 digits, 10th digit and 1st digit, if that 2-digit number is divisible by 4, the whole number is divisible by 4. Nice result, right? This you need to remember, right? So you need to remember things, right? Even in mathematics, there are things to remember, but much less than lots of other subjects, right? So what 2 digits in the last 2 places are divisible by 4? Of course, we need to include 0 and 0, right? See, there is 0, it is divisible by 4, right? and 0 2 no 0 4 yes, right? And then we go with 2 in the tens place, and then 0 in the ones place. This is by 4, right? 2 2 no 2 4 yes, and then 4 in the tens place, 4 0 yes, 4 2 no, 4 4 yes. So how many are there? So we have 6. So these 2 digits can be any one of those 6. If any one of those 6, then it is divisible by 4. Doesn't matter what is in the thousands place and what is in the tens, hundreds place. So the thousands place can be 0, can be 2 or 4, can't be 0. So 2 choices. And the hundreds place can be any one of those 3. And then if you multiply these choices, number of choices by each other together, right? So 2 times 3 times 6 is actually 36. So there are actually 36 4-digit numbers consisting of digits 0, 2, or 4, which are divided by 4. Now this is actually by the multiplication principle. Now this is something you need to learn, but you don't need to learn this in its full we can even in this problem we can learn it, how we use the multiplication principle. That's also another way of learning, right? So there's a principle called multiplication principle, and by that we multiplied. And even without knowing it, you can see that, yeah, if you multiply, we get all possible possibilities for this 4-digit number, right? So the answer is 36. And that is the last question in the last 8, right? So I have finished SLJMCC 4 paper given last year, and the easy and medium questions in SLJMCC 5. Okay. In the next video, I'll discuss the hard questions in SLJMCC 5, last 8. Okay.